In this video, we're going to unlock the secrets of mathematical notation. We'll explore how to decode those seemingly complex symbols, Greek letters, and conventional meanings that often make math appear so daunting. Get ready to transform your understanding and take away the fear. Let's confront the fear factor. Take a look at this equation. Integral from -infinity to infinity of e to the power of -x squared divided by 2 sigma squared, dx equals sigma times the square root of 2 pi. At first glance, this equation might seem intimidating. However, it's essentially expressing a simple concept about the areas under curves. By breaking it down, we can reveal the simplicity hidden beneath the complex notation. Think of mathematics as another language. On one side, we have English, which might express a concept as the sum of all numbers from 1 to n. On the other side, math uses its own notation to express the same idea. Sigma I, where I equals 1 to n. Both convey the same meaning, just in different forms. Understanding this equivalence can make math less mysterious. Greek letters are frequently used in mathematics and science. Here are a few common ones. Alpha, represented by the symbol alpha, is often used to denote angles or coefficients. Beta, shown as beta, is also used for angles and sometimes for parameters. Pi, symbolized by pi, represents the well-known circle constant. Theta, written as theta, typically denotes angles. Lambda, shown as lambda, is often used to represent wavelength. Finally, mu, written as mu, can represent the mean or friction. Mathematical symbols can be grouped into categories based on their function. First, we have operations like plus, minus, multiplication, division, summation, integration, and product. These symbols represent actions you perform with numbers. Next, there are relations such as equals, not equals, greater than, less than or equal to, greater than or equal to, and approximately equal to. These symbols show how different values or expressions compare. Finally, there are sets, which include symbols like element of, not an element of, subset of, union, intersection, and the empty set. These symbols deal with collections of objects and their relationships. Superscripts and subscripts are used to add detail to mathematical notation. Superscripts, like in x squared or 2 cubed, appear above the line and are often used to denote powers or exponents. Subscripts, such as in x1 or h2o, appear below the line and are used for indices or to indicate quantities. The meaning of a symbol often depends on the context in which it's used. Take the Greek letter sigma, written as sigma. In statistics, it represents standard deviation. In physics, it can represent stress or conductivity. In chemistry, it denotes a sigma bond. And in mathematics, it represents summation. Therefore, always consider the context to correctly interpret a mathematical symbol. Let's break down a seemingly complex expression. On one side, we have the integral from 0 to infinity of x times e to the power of -x dx. This might look intimidating with its symbols and notations. However, it simply represents the area under a curve. It's just a method for finding the area between a line and the x-axis. By understanding the underlying concept, the complex notation becomes much less daunting. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.